Hello everyone and welcome to another Physics 211 lab simulation walkthrough. My name is Alec Lancaster and today we're going to be going back in time a little bit to the beginning of the class when we talked about capacitors. I know this wasn't exactly what we had on the schedule for today, but because, I scoured, truth be told, I scoured the internet for a lab simulation that would be suitable for our needs and could not find one. So instead of talking about spectroscopy, we're going to go back and review a little bit about capacitors, seeing as how we didn't get to work with them all that much in the first place. So I'm going to let you read through this theory and equation section on your own time, since, of course, you've already gone over much of it. And let's jump right in. So we're going to start off with a single capacitor and verify some of the equations that we've learned based off of that. So first of all, click the introduction thing on top of the page. Check the plate charge button, and I know things might click both of them actually. I know things might be a little bit small for you, but unfortunately for some reason the simulation likes to mess up if I zoom this in any further. I can kind of show you what I mean. So if I zoom this in further and hit a button, it just goes haywire. So unfortunately we're going to have to deal for today and work like this. But of course I'll try to read all the values out as clearly and concisely as I can, or of course you can just run the simulation on your own at home to take the data. So now we're told to click the plate charge button on both of those meters here, so we've done that, and then to set the battery to 1.5 volts. Now what we're going to do is set the separation to 5 millimeters and the plate area to 100 millimeters or 100 square millimeters, and we're going to be reading off the charge here and calculating the capacitance based on the voltage and the charge that we get to verify equation 2. Alright, so let's get started. So we're told to record the charge on the capacitor in the table below. As you can see down here, I've created some nice tables for you to enter your data into, but of course if you'd like to just enter things into Excel and do that yourself, go for it. Actually, I would almost recommend that. And let's see here. So we are told to record the charge on the capacitor. So the plate charge, it says, is 2.66 times 10 to the negative 13th coulombs. Also, from kind of now on, just remember that every charge that I'm going to be reading to you is in 10 to the negative 13th coulombs, just because that's pretty much the maximum of the range that we can acquire here. And of course the separations are in millimeters, the plate areas are in square millimeters, so I'll just read off the the number values, but make sure that you remember which ones they are, or what the units are. And so again, we have 2.66 times 10 to the negative 13th coulombs for a separation of 5 millimeters and a plate area of 100 square millimeters. Now, moving on, we're told to repeat that over and over again for all of these arrangements down here. So we're going to set our separation to 6, and I'm going to do my best to set it to exactly 6. It might not work out that well. Okay, great. So now we're going to record the charge at a separation of 6 millimeters, and we're leaving the plate area fixed at 100 square millimeters for now. So we get a charge of about 2.2, and remember that's times 10 to the negative 13th. I'll stop reading that off now. Next, we bring the separation up to 7. And it doesn't have to be exact, just close to it. So like I can't exactly land it on 7 here, so I'm just going to land it on 7.1 and call that good enough. So for 7.1 we get 1.88, or a charge of 1.88, and I'll try to move up to 8 next. Alright, so again it's giving me trouble trying to land on exactly 8, so I'm just going to say 8.1. There we go. Alright, so for a separation of 8.1 we get about 1.64 coulombs, or sorry, times 10 to the negative 13th coulombs. And for separation of 9, we get about 1.48. And finally, for separation of 10, we get 1.33. So make sure that you've entered that into your data table down here or into Excel or whatever. And once you've done all of that, go ahead and calculate the capacitance based on equation 1 for all of those situations. Alright, and now that we've done that, we're going to bring the separation back down to 5, and we're going to edit, or we're going to change the plate areas in increments of 100. So of course you already did the first one, which was the separation of 5 and plate area of 100. So now I'm going to increase the plate area to 200. And again, remember this is in square millimeters. And again, it's going to be tough to land it exactly on 200, so as long as you mark down the actual value, you should be just fine. Let me see. Okay, so I have 202.3 here for the plate area, and a charge of 5.37 coulombs, or times 10 to the negative 13th coulombs. So I'll increase it to 300 now. Again, make sure you mark that value in the table below. And okay, so for 299.2 millimeters, square millimeters, I have a charge of 7.95, and for a charge of 400, or for a plate area of 400, sorry, I've got a charge of 10.62. And do bear in mind for this entire time, we've left our voltage fixed at 1.5 volts, so you'll be using that as the denominator for this equation pretty much the entire time. All right, so with that, let's move on to part 2. Hopefully you have both of those tables filled out now. Okay, so moving on to part 2, we are told to click on the multiple capacitors button, and then we're going to click 3 in series, and then make sure that the stored charge is still checked here. And then we're going to set the capacitances, sorry, let me rescale this here. We're going to set the capacitances to 1, 2, and 3 times 10 to the negative 13th microfarads, respectively. So I'll have 1 up here as 1. This one's 1. Set this one to 2. And then set this one to 3, which is all the way up. And now what I would recommend you do, I will not do it for you, is calculate the equivalent capacitance for this arrangement and record it in the table below, which you'll see down here. And once you've done that, go ahead and set the battery to 1.5 volts and record the stored charge of the capacitor for that arrangement. So for this arrangement, I get a capacitance of 0.82 times 10 to the negative 13th coulombs. So go ahead and write that down in your charge stored section here, right next to your equivalent capacitance that you have calculated. And next, what we're going to do is we're going to go over to the 3 in parallel section and set the capacitances equal to the same values as before. So 1, 2, and 3 times 10 to the negative 13 farads. And once we've done that, we're going to set the we're going to calculate the equivalent capacitance for this arrangement, which I will allow you to do on your own time. And again, keep the battery at 1.5 volts. And then record the stored charge of the capacitor arrangement. So the stored charge of this arrangement is 9 times 10 to the negative 13th coulombs. So go ahead and mark that down here in the charge stored section. So now what you're going to do, I'm not going to do this for you, but I'll kind of walk you through it with words, at least for these sections here. So for this section's data, you're going to use equation 1 to calculate the equivalent capacitance of that series circuit. And then just make sure that the equivalent capacitance that you calculated, using the two rules that we have, where the capacitances add inversely in series and then the capacitances add normally in parallel, make sure that you were able to calculate the equivalent capacitance, again, given the charge stored for that section, and make sure that those two things were the same. And then, of course, you're going to make a couple graphs and then answer some questions, and you'll be good to go. So, all right, thanks for watching, everybody. Have a great day.